Okay, geometries, this is Mr. Bloom. I'm flipping arrows all over the place. Let's fix that. This is Mr. Bloom. Lesson 6.5, conditions for rhombi, rectangles, and squares. Oh my. Our objectives today. Students will be able to determine whether a parallelogram is a rhombus or a rectangle. Okay, so let's get going on here. Now, keep in mind our essential understanding. You can determine whether a parallelogram is a rhombus, a rectangle, based on the properties of its diagonals. You can determine if it's a rhombus or a rectangle. So we're going to look at properties of diagonals here. Okay. Now, this next thing, comparing properties of our diagonals. So if in this theorem, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay. We got perpendicular diagonals, rhombus. Okay, so keep that in mind. So if I got perpendicular diagonals, then this parallelogram is a rhombus. All the sides are the same. So now let's look at that with this next one. If one diagonal of a parallelogram bisects a pair of opposite angles, okay, if one pair of, excuse me, just got to hop back here, got to come back, and we got to go back up. That just freezes sometimes. So now we're looking at this parallelogram. It's bisecting. This one angle is bisecting the two. So, okay, angles. Then the parallelogram is a rhombus. So if I have a diagonal that cuts an angle in half, and it's a parallelogram, but these are congruent to each other, then I can assume it's a rhombus. So keep in mind, I got one diagonal. See if we can get that come down a little bit. One diagonal bisects a pair of opposite angles. Rhombus. Keep that in mind. Okay, so now sliding on here, let's look at diagonals of a rectangle. Now, this theorem, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if I got diagonals are congruent, then we have a rectangle. Okay, so keep that in mind. If the diagonals are the same, AC is congruent to segment BD, segment to AC is congruent to segment BD, then we know this is a rectangle, right? So this is a rectangle. This is about a rectangle diagonals. And these two are about rhombus diagonals. This is about a rhombus as well. Okay, just a hint. That's what these are about. Okay, it's nothing special. It's not a name. It's just kind of like listing things that we know. We want to make sure it's clear which one belongs to. Now, sliding on. Identify the special parallelograms. Well, if I'm looking at this, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain. Well, I got a diagonal that's cutting two sets of angles in half. Diagonal cuts two sets of angles in half. Well, back here, I saw a diagonal cut two sets of angles in half. It's right here, Theorem 617. Well, that means that shape over here is a rhombus. So yes, a diagonal bisects two angles by Theorem 617. This is a rhombus. Now, over here, I've got diagonals that are bisecting each other, okay? They're bisecting each other. That's pretty much what a parallelogram does, but notice that they're the same size. They're the same size here. So that makes these diagonals the same length and they're perpendicular. So if I can prove that this is a rhombus, rectangle, or a square. So yeah, I can do that. And diagonals are congruent. By theorem 618, this is a rectangle because they're here and they bisect each other, but I'm adding two of the same measure together. So they got to be the same. And here the diagonals are perpendicular. So by theorem 616, this is a rhombus. But when I have a rectangle and a rhombus, I can think about the rectangle rhombus. That's a square. A rectangle has 4 right angles, and a rhombus has 4 sides the same. So this is a square. Okay? Now, sliding on, a parallelogram has an angle measure. Let me get my little pointer back. A parallelogram has an angle measure of 20 degrees, 160 degrees, and 20 degrees, and the final one is 160. So if I drew a picture of this, if I have a parallelogram, and let's pretend my picture's absolutely perfect, 160 and 20 and 160. If this were true, I know it's not drawn to scale, but if it were, okay, can I call it a square, a rhombus, or a rectangle? Well, right now, because it has no right angles, I know it's not a square or a rectangle. Okay, this shape cannot be a square or a rectangle, no right angles. Okay, but, no buts. I don't know anything about the side measures. I don't know anything about the diagonals bisecting or being perpendicular. So this shape could be a rhombus, but we need more information. Side measures congruent, a diagonals perpendicular. So, and I cannot come to any conclusions at this time. It's just a parallelogram. So it's just a parallelogram until we have more information, okay? And we'll find out what that would be at some future time. Now, using properties of special parallelograms, for what value of x is the parallelogram a rhombus? Now, by 617, we just learned if we use 617, we've got to know that these two angles must be the same. This diagonal has to bisect this angle ABC. So if that's true, I've got to be looking at the idea of 6x minus 2 is equal to 4x plus 8. So I subtract 4x and I get 2x minus 2 is equal to 8. I add 2 and I get 2x is equal to 10 and x is 5. Now they ask me for what value of x, but I need to check my work. 30 minus 2 is 28. And I got 5 times 4, which is 20, which is plus 8, which is also 28. So they are the same value, so I'm happy with my solution. So x is 5. Here, for what value of y is the parallelogram DEFG a rectangle? Now keep in mind, in a rectangle, the two diagonals must be equal. And since it's a parallelogram, the diagonals have to bisect each other, but in a rectangle, those diagonals are the same. Okay, so I would have to show that the halves of the rectangle diagonals, the two halves would be the same. So 5y plus 3 is equal to 7y minus 5. So 3 is equal to 2y minus 5. 8 is equal to 2y, and 4 is equal to y. Now let's plug it back in. 5 times 4 plus 3 is equal to 23. 7 times 4 minus 5, well, it's also 23. Okay, awesome. It works. So our answer is 4. Now, the shapes below are parallelograms. What is the best name for each? Rhombus, rectangle, square, or parallelogram? Okay, the shapes below are parallelograms. What is the best name should say it this way. The shapes below are parallelograms. What is the best name for each rhombus, rectangle, square, or parallelogram? No, those are the four options. Remember, they are already parallelograms. Okay? So, in this first one, in number 1, NP is congruent to QP. Well, I know that if I have congruent diagonals, I have a rectangle. So this is a rectangle by theorem 6.18. Did you notice I justified my solution? So I know that's right and I get to move on. Now in 2, I have diagonals that are perpendicular. That's this right there. It's a parallelogram with perpendicular diagonals. So this is a rhombus by theorem 6.16. Okay, and that talks about perpendicular diagonals for rhombuses. In 3, we're looking at this. Okay, so now that you've got this idea, I want you to look at 3, 4, 5, and 6 and do them on your own. Turn it off, do them on your own, and then turn it back on and see how you do. In 3, it looks like they're trying to lead me down this primrose path of rectangleness. Well, here's the thing. I'm not told that OQ is congruent to RP. I'm just told that I have a parallelogram. I'm not told that I have angles that are congruent because of those diagonals. I'm not told about side measures. Excuse me. I'm not told about anything else. So right now, I just have this. And by the way, that's the sign for parallelogram. Okay. Now in 4, I have 2 angles, and they're trying to show that they're at different levels here. 2 angles that are cut in half and they're congruent across the diagonal. So I have a diagonal bisecting 2 angles on the inside of the shape. So this is a rhombus by theorem 6.17. Okay. Now we slide on in number 5. I have a diagonal that's perpendicular. And at the beginning of all this, I'm told that all of these are parallelograms. But perpendicular diagonals is a symptom, a property of rhombuses. So this is a rhombus. And that is by theorem 6.16. Now in 6, they got a diagonal all for me. And that's awesome, but they don't have the same markings. They have the same markings there. So this is cutting each other in half, but that's a parallelogram that has diagonals that are bisectors of each other. It is not a rectangle, at least based on properties provided. So this is a parallelogram. And remember, just writing this shape shows that it's a parallelogram as well. Now, in 7 and 8, these are different looking. Turn me off and figure out what it is and turn it back on. Okay, welcome back. In 7, I have opposite sides congruent, and they're all the same measure, so all sides the same. That's a rhombus. And I should say all sides congruent. Congruent, that's a rhombus. But I've got a rhombus that has all 4 right angles. Well, that's a rectangle. Well, if I've got a rhombus rectangle, I really have a square. Okay, that's a square by definition. All the sides are the same, all the right angles are the same. Now in 8, boy, that looks a lot like it. That could totally be a square, except for the fact that these are different and these are different. So this is just a rectangle. And that's by definition, because I'm looking at this fact of what's going on, and it's got 4 right angles. That's how I know it's a rectangle. All right, I hope these things are going well for you. Okay, let's talk about our summary. Our objective today, students will be able to determine whether a parallelogram is a rhombus or a rectangle. Okay, you're supposed to write a couple sentences about something that you learned today and about the learning objective, then rate yourself on a 0 to 4. Now, after you do that, let's check this out. Because what we've been doing, we've done our quadrilateral stuff, we've done parallelograms, but today was about rectangles, rhombuses, and squares. So we get to add to our note sheet for our test. Okay, so make sure you know that the properties of rectangle, 4 congruent right angles and diagonals are congruent, and for a rhombus, 4 congruent sides, diagonals are perpendicular, diagonals are bisecting interior angles, and diagonals make 4 congruent right triangles. So keeping that in mind as we go through this, you've got to be aware what the properties are. Now, again, after you get those down, go to this last page and check off what you know. Well, I hope these things are going well. Again, this is 6-5 for geometry notes. And if you have any questions, find your local geometry teacher and ask them. Well, I'm Mr. Bloom, and you're not. Have a great day.